Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this video, we're going to be introduced to the idea of coterminal angles. So let's go ahead and get started. Now, when we're talking about coterminal angles, let me go ahead and draw my, I need a different color there, obviously. When we're talking about coterminal angles here, we're talking about the following. All right, yeah, that's nice. Okay, so then I just draw my nice little, same problem with the. So with coterminal angles, try to make this nice and straight. So here's my unit circle, if you will. And with a coterminal angle, what you essentially have is when an angle has the same, two angles have the same terminal side. So let me see if I can make this as clear as possible for you. So take a look at the following. So, all right, this is going to be my initial side right here. And then right here, this is my terminal side. So for this guy right here, the angle is 90 degrees. Because if you notice carefully, when I drew this, I'm looking at it going counterclockwise, which is what you do when you're doing standard position. Now, here's the thing: if I go clockwise, it'll be negative. So let's see here. I start here is 90, so it's going to be negative 90, negative 180, negative 270. So to go all the way around like this, I now have a negative 270. But these are coterminal angles because, again, like I just told you, they have the same, they have the same terminal side right here. They have the same terminal side. And this is what makes them coterminal angles. That's what it is, starting from standard position. Now, this is important because sometimes when we're doing things involving angles and radians, it's normally easier to deal with angles that are between 0 and 360 degrees. In other words, when something goes beyond 360 degrees or when it goes below 0, it becomes difficult, not impossible, but difficult to calculate and do things on a practical level. So there are, of course, ways to address this. So when we understand the ideal of coterminal angles, let me give you a practical example. If, for example, your angle is greater than 360 degrees, so for example, mine is going to be 900, what you do is this: you subtract 360 degrees until your final angle is less than 360. So here's my 900 degrees. So if I subtract 360, then it'll go down to 540. I'm still not done yet. I subtract another 360. And it goes down to 180 degrees. So when I'm trying to calculate and do something, I will use this because 180 degrees and 900 degrees have the same coterminal angle. And so if I had to, prove this to you, if that was necessary, it will look something kind of like this. So I have my, actually I don't even need the circle. I can just draw the axes here. I just draw my axes like that. And like that. All right. Now, if I had to draw this is going to be kind of awkward. So first I go counterclockwise, and so no, clockwise, because I want to get to 900. So I guess it doesn't really matter. So for this one, it would be, let's see here, 90, 180. 270, 360, and then it would be, let's see here, 450, 540, 540, then 630, then 720, then 810, then 900. So right there. So now notice carefully, this is going to be 900 degrees, like so. Now here's the thing: if I do 80 degrees, again starting right here, but if I do 80 degrees, it's going to be 90, 180, and so right there. You can see that they have the same terminal side, and it's the same equivalent expression. So 180. They're the same thing. That's why you use 180 instead of 900. Now, in another example here, if I have a negative angle, this is a slightly different problem. Instead of taking away, or instead of adding 360, if I have a negative angle, instead of taking away 360, I add 360. So let's say I have the angle negative 540. So what do? You just add 360. So plus 360, that'll get me to negative 180, not quite, plus 360, and now I'm at positive 180. There we go. And so again, if I had to draw you a picture of this for those of you who are visual learners, try to make this as clear as possible. It's not as easy as it looks. All right, so since I'm negative, I'm going to go clockwise. That's what I'm going to I'm going to go clockwise. So I'm going to start down here. So this time I'm going to go clockwise. So this time I'm clockwise. So negative 90, negative 180, negative 270, negative 360, negative 450, negative 540. So right there is negative 540. And of course, again, if I go clockwise, or if I go counterclockwise, I just go in the opposite direction. This is 180 right here. Voila. You can see it right there with your own eyes. This is how it works. Now, you might be wondering, well, what about with radians? Well, it's the same idea. If your value is greater than 2 pi, you need to subtract 2 pi until it's below that. So again, to give you an example, if I have 11 pi over 4, this is not that complicated to deal with. All we have to do is subtract 2 pi from both sides, or not from both sides, but just subtract 2 pi. So 2 pi, and of course they have different denominators obviously, so you got to deal with that first. So it's going to be 11 pi over 4 minus 8 pi over 4. In other words, you can see I just multiplied the top and the bottom by 4 here. And so now I get the answer of 3 pi over 4, like so. So you can see that that's pretty much the answer. Now, of course, if you're dealing with negative radians, you're going to have to add 2 pi to both sides. So again, following the same logic here, 17 pi over 6. Now it's going to be plus 2 pi. Remember, I'm just going to put the 1 here for consistency. I multiplied the second one by 6. The first one you multiply by 1, so it doesn't change anything. Negative 17 pi over 6 plus, looks like it's going to be 12 pi over 6. And so now I have negative 5 pi over 6. I'm still having the problem of it being a negative radian, or negative pi's if you will. So again, I add. Now, just to save time, I already know what I have the same denominator here as here, so that means I can reuse this 12 pi over 6. So I don't have to like calculate and think about it. So now I end up with, let's see here, 12 pi over 6. Subtract that. Now I have 7 pi over 6, and this is less than 2 pi over 1, or just 2 pi if you will. And that's pretty much how you get the answer. So you can see that this is a practical way to deal with things, and again, this is a useful skill and tool that's going to be very applicable for more advanced analysis in the future. So let me rewind, recap what we did, and then conclude the video. So in this video, we talked about coterminal angles. So coterminal. And coterminal angles is essentially when, two angles have the same terminal side. That's why we call them co. And so when you're dealing with that, you can use that knowledge of them having the same side to try to simplify things. In particular, this is useful when you have an angle that is greater than 360 degrees or greater than 2 pi, or when you have an angle that is less than 0, a negative angle, or you have negative pi values or whatever if you're dealing with radians. And if your angle is greater than 360, you subtract 360 however many times is necessary until the angle falls within the threshold of 0 to 360. If you're dealing with a negative angle, you add 360 until it becomes positive, however long that takes. With radians, If the radians are greater than 2 pi, you subtract 2 pi until it falls within that range. And of course, if you are dealing with negative pi's, you add 2 pi until you get within the acceptable range. So I hope that this was useful for you and you were able to understand what we were talking about. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.